Good afternoon, Dr. Marie, to the audience. So we are going to report on the Exxon Valdez oil spill of 1989. And with me in this report is Nabil Sami. Okay, so on March 24, 1989, the oil tanker Exxon Valdez ran aground on a charted rock at the Bligh Reef in Prince William Sound, Alaska. So the grounding occurred after the vessel left the designated tanker lanes to avoid icebergs that were reported to be in the area. So the tanker spilled an estimated 11 million gallons of Alaska North Slope crude oil, and the ecologically sensitive location, season of the year, and the large-scale spill resulted in one of the largest environmental disasters in the U.S. history. So this is the map that shows the geographic extent of the shoreline contamination of the oil spill. So highlighted here is the initial spill site and the coastline contaminated by the oil, that's shown in red. So you can see the paths where the oil was transported by the wind, currents, and tidal actions. Okay, so the oil spill primarily involved crude oil, which contains polycyclic aromatic hydrocarbons and other aliphatic and aromatic hydrocarbons. These contaminants, particularly the PAHs, are toxic and persistent and were the main source of pollution from the spill. Okay, while the crude oil was the primary contaminant, some cleanup chemicals like the dispersant Corexit were also used, and the components like 2-butoxyethanol in the dispersant were associated with health issues or among cleanup workers. Although the overall use of these dispersants are less documented than the oil itself. There were also fertilizers that added nutrients during the bioremediation process, where nutrients were added to the environment that encourage the natural breakdown of oil. Now we move on to geotechnical and environmental factors. So the physical environment of Prince William Sound played a major role in how the Exxon Valdez oil spread and persisted. The region has rocky shorelines and fractured bedrocks, which allowed oil to seep deep into the cracks and crevices, making cleanup extremely difficult. Mixed sand and gravel beaches also contributed because their high porosity led to oil penetrate far below the surface, where it stayed for decades in low oxygen conditions. Also, the sheltered coves and mussel beds created low oxygen zones, where oil accumulated and remained trapped. So altogether, these factors significantly worsened the contamination and slowed natural recovery. So another major influence on the spill's behavior came from the soil, groundwater, and ocean conditions in Prince William Sound. So the permeable sand and gravel beaches allowed the oil to migrate vertically and become trapped below the surface. Because these subsurface layers were very low in oxygen, biodegradation was extremely slow, which helped the oil persist for decades, and that was made even worse by the cold Arctic temperatures that slowed chemical breakdown. And another thing is the hydrodynamic conditions that also played a big role. The strong tidal actions, sometimes reaching up to 4 meters, repeatedly spread across intertidal zones. Ocean currents then carried the contamination along more than 1,900 kilometers of coastline, even reaching remote islands. So the powerful April storm events pushed oil deeper into sediments and accelerated its spread.
Hi, this is me, Nabil Sami. So I'm gonna cover rest of the slides. So let's talk about the impacts. And honestly, this is where the Exxon Valdez spill went from bad accident to environmental nightmare. So let's talk about environmental and ecological impacts. So first, wildlife took a massive hit. Around 200 and 800 sea otters were killed. 300 harbor seals, sea lions, and porpoises died. 22 killer whale pods impacted. Some have not recovered to this day. Birds estimated 250,000 seabirds died due to oiling spill. Moorings, puffins, and cormorants are heavily affected by the oil spill, and they are like that's the highest recorded mortality in North America till this date. And for fish and shellfish, the disaster kept echoing for years. Herring stocks collapsed, salmon eggs were exposed to PAHs, and contaminated mussel beds kept leaking toxins back into the food web. Let's talk about the human impacts, like impact to human communities. So Exxon Valdez spill also had a deep and lasting impact on human communities, like indigenous group, Alutiiq, Yak, and Chugach people lost food sources and their traditional harvesting methods. This made a cultural disruption which is still felt these days. Fishing industry collapsed, billions in losses. Tourism dropped, long-term economic damage. The region lost their reputation and their lifestyle. Over $7 billion spent in cleanup and damages. Long-term lawsuits, which took decades for the settlement. So these are the impacts. Let's talk about the remediation efforts. So right after the spill, the first remediation effort focused on mechanical recovery. So booms and skimmers were used to contain and recover floating oil. The effectiveness was limited. 10 to 15% of the spill oil was mechanically recovered. Then comes the manual and physical cleanup. Hot water, high pressure washing of shorelines used to remove oil from rocks and sediments, but the result was controversial. Killed the intertidal microbes and slowed the ecosystem recovery. Then they used manual removal, like workers and volunteers hand collected tar balls, oil debris, and contaminated sediments. So it was a slow process and labor intensive, but it worked on those areas where machineries could not reach. So remediation, then comes the bioremediation. So one of the most effective cleanup methods used after the spill. So this involved applying nitrogen and phosphorus fertilizers to the shoreline to stimulate naturally occurring oil degrading microbes by boosting microbial activity. This technique significantly increased the rate of biodegradation and become one of the most successful remediation approaches. So recovery so far, as you can see from this infographic by NOAA, you can see bald eagle, some species like bald eagle, salmon, and others, they have recovered so far after the oil spill. But others such as killer whales, herring, and some seabirds population are still recovering and have shown little improvement. Few species remain in uncertain condition. So overall, the recovery has been slow and uneven, even after decades later. So researchers have tracked lingering subsurface oil from Exxon Valdez spill for decades. In 2015, Lindbergh and colleagues revisited the site where oil was still present. They found that the chemical composition of the oil hadn't changed much, and the location and amount of subsurface oil remained nearly same as in earlier years. Today, about 0.6% of original oil remaining in Prince William Sound, slightly more than earlier estimates, showing just how persistent this contamination can be in low oxygen sediments. In summary, the Exxon Valdez spill was made worse by the geotechnical and coastal conditions in Prince William Sound, which allowed oil to sink deep into sediments and slow recovery. Cleanup efforts helped, but they were only partially effective, leaving long-term geological impacts. Overall, this disaster shows how important it is to integrate geology, engineering, and environmental management in planning future oil spill response strategies. So thank you for listening. These are the references we have used to make our slide. Thank you.